All right, let's get right into it. We're going to talk about something absolutely critical to our food system, the honeybee and the massive threat it's up against. But this isn't just a doom and gloom story. It's also about a really incredible new hope that's just emerging.
First up, I want you to just take in this number, 62%. That's the average loss of colonies that commercial beekeepers have had to deal with in less than a single year. I mean, can you imagine any other industry losing almost 2/3 of its essential workers? It's just staggering.
So, you've got to be asking, what on earth is causing this? It's a complicated mess for sure, but it turns out there's one prime suspect right at the heart of it all.
Now, before we unmask the culprit, we really need to get a handle on the stakes here. Because this isn't just about losing honey, not by a long shot. This is a quiet crisis, one that has huge implications for our farms, our economy, everything. Get this, we're talking about more than 100 different crops right here in the US that need honeybees to pollinate them. All told, that's worth an estimated $20 billion to the economy every single year. From the almonds in your granola to the blueberries in your muffins, our plates would look a lot different without these little guys. Okay, so with the stakes that high, it's time to meet the number one enemy responsible for these terrible losses. Everybody, meet Varroa destructor. Yeah, its name pretty much says it all. This tiny parasite is a total wrecking ball for bee colonies. It latches onto bees, feeds on their fatty tissues, and, this is the real kicker, it acts like a dirty needle, spreading all these deadly viruses that can just tear through an entire hive.
And you don't have to take my word for it. Jason Miller, who's a fifth-generation beekeeper, puts it as plainly as you can. It is the number one enemy. For people who've built their lives around healthy bees, Varroa is this constant, horrible threat.
And the way this thing works is just nasty. It attacks baby bees when they're at their most vulnerable, while they're still developing inside their cells. So it weakens the next generation before they even hatch, which pretty much guarantees the colony is going to collapse, slowly but surely.
So at this point, you're probably thinking, well, come on, surely we have something to fight this thing, right? And the answer is, yeah, we do. Or actually, we did. The problem is, our enemy is getting smarter, and our old weapons, they're just not working anymore.
For a long, long time, beekeepers have been using these chemical treatments. They're called miticides to try and control Varroa. But it's just like how bacteria become resistant to antibiotics. The Varroa mite is adapting, it's evolving, and it's becoming resistant to the very chemicals designed to kill it.
And let me be clear, this isn't some far-off what-if scenario. It is happening right now. The mites are evolving, the treatments are failing, and beekeepers are just running out of good options. It's so bad that up in Canada, beekeepers are actually calling for huge nationwide studies into resistance against one of the most common treatments, a chemical called amitraz.
Just look at where this is headed. We're already at 62% losses. And researchers at Washington State University, they're projecting that if we don't do something big, that number could hit 70% next year. I mean, we are flying straight towards a cliff.
But this is where the story gets really, really interesting. With all the old methods failing, scientists had to think completely outside the box. They decided that instead of just trying to poison the mite, maybe they could hack it from the inside out. This brings us to this amazing technology called RNA interference, or just RNAi. Now stick with me here. It's actually a natural process that our own bodies use to turn specific genes on or off. Scientists have figured out how to use this process to create a very specific message. Think of it like a secret self-destruct code that only the Varroa mite can understand.
So here's how it actually plays out in the hive. The treatment, which has this special RNA in it, gets shared around by the bees. When a mite comes along and feeds on one of those bees, it swallows the RNA. That RNA code then goes to work, finds a super important gene inside the mite, and just flips the off switch. And with that one gene silenced, the mite can't reproduce anymore. The whole infestation just collapses from within.
And look, I know this sounds like something out of a sci-fi movie, but it's not. This technology is real, it's been developed into an actual tool, and it offers the first truly new way to fight Varroa that we've seen in years. The breakthrough is a product called Varroa. It is the very first RNA-based treatment for Varroa mites, and it's already been officially approved by the EPA here in the US. It's real, and it's here.
So how does this new stuff actually stack up against the old chemical treatments? Well, where those conventional miticides are often like a chemical bomb that can hurt the bees too, this RNAi treatment is like a sniper rifle. It only affects the mite.
And because it's a totally new way of working, the mites have no resistance to it. Plus, unlike some chemicals that can stick around in the hive, this stuff breaks down really quickly.
For the beekeepers on the ground, the advantages are just a total game changer. You're getting up to 18 weeks of mite control from just one treatment. It's totally safe for the whole colony, the queen, the workers, even the babies. And it's way more flexible to use. Oh, and the active ingredient? It's based on something that's already found all over in nature.
And this really gets to the heart of what they were trying to do. As Andre Zarur, the CEO of the company that made this, put it, the whole point was to create an environmentally conscious solution. It's about targeting the bad guy without all the collateral damage. That's really the holy grail.
So when you zoom out, what this really all means is that we have a brand new, super targeted weapon to protect these pollinators that are so important. And when we protect the bees, let's be honest, we're really taking a huge step towards protecting our own food supply for the future.
Which kind of leaves us with this one final wild thought. For decades, we fought these battles with poisons and chemicals. But as we're facing these evolving threats in this incredibly delicate ecosystem, could it be that the future of saving our best allies is actually rewriting the code of our worst enemies?